The quadrilateral family. Each of these shapes has 4 sides, and all of the interior angles measure 360 degrees. 360 degrees is in a complete circle. The 3 vertices of the triangle gave us 180 degrees. If we cut any quadrilateral on the diagonal, we're going to get 2 triangles in the quadrilateral. So it only makes sense that 2 triangles, 180 plus 180, gives you 360 degrees within the interior angles of the quadrilateral. So we've actually taken a shape and made 2 triangles out of that shape. That's how we get the 360. We have a parallelogram, rectangle, rhombus, square, trapezoid, and kite. Those are the formal names of these geometric shapes. So let's take a look at each one separately and see what the attributes of those shapes are. Let's analyze a parallelogram according to its attributes. You may want to jot these down in your notebook. You'll use them over and over again when you're trying to decipher what a shape is and how to prove that it is this particular shape when you get into some geometry. It's also on a lot of the tests that you'll have for college entrance, or if you're trying to get into a private school. So, opposite sides of the parallelogram are parallel. So this would be a pair of opposite sides, and this would be a pair of opposite sides. So we would show our parallel with this symbol. It's like a little arrow, and it goes on the sides that are actually parallel. These 2 sides are also parallel to each other, but I can't use just one arrow because that tells me that it's parallel to this. I'm going to need to have 2 because that's parallel to this side. The opposite sides are congruent. That means they measure the same. So this side of the parallelogram would be the same length as this one. This side matches this side. Obviously, these are longer, but this side is the same measure as that side. Opposite angles are congruent. That means our opposite corners are the same measure. Opposite corners, the same measure. So this would be the same measure as that one. And this one is the same measure as this corner. The consecutive angles measure 180 degrees. Well, consecutive means in a row. So if we were to label these A, B, C, and D, our consecutive angles to A would be either B or D. If we were consecutive angles with B, it would be C or A. The consecutive angles then measure 180. Parallelogram, all quadrilaterals measured 360 degrees in the interior angles. So if I just took 2 angles that were side by side, I would have half of that. And half of 360 is 180. So if our angles measured 100 for A, then C would also have to be 100 because they said before that the opposite angles were congruent. If D measured 80, then B would have to measure 80. And if we were doing consecutive angles, we would have a large angle with a small angle, a large angle with a small angle, a small angle with a large angle, a small angle with a large angle. 100, 100, that would be our A, plus D, 80, is 180 degrees. If we were at A and we were doing consecutive to B, A plus B, A was 100, B was 80. So we would have 180 degrees. The consecutive angles measure 180 degrees. The diagonals bisect. That means they cross, and they cross midway. So if I did a diagonal from 80 to this angle D to angle B, do you see how I would make two equal triangles of this? Now if I did the other way and connected C and A, I would still have two triangles in this, and these would be equal. If I put the other diagonal back, they cross each other and make these two parts of this line equal or congruent. That's the term that they use for equal, congruent. And this part of the diagonal would be the same as this, 2, 3, 4. The diagonals bisect. That means they cross, and bisect means to cut in exact half. They divide into two equal triangles, as we saw before, and the line itself, this half of the line is the same distance as that. This part from here to the middle is the same as from the middle to the corner. One pair of opposite sides, both parallel and congruent. So that means this, if I can get the top and the bottom to be parallel to each other and congruent, we can call this a parallelogram. The same thing with the other two sides. If I can get a pair of opposite sides, these are opposite sides. If I can get this one to be parallel to this and this to be the same measure as that, I know that I could call this a parallelogram without having to worry about diagonals or consecutive. This would simply be enough information to be able to call that a parallelogram. I mean, I call this pen. I call this a playing card. It has attributes. These are the attributes of a parallelogram.